Hi, this is John Wells here from the Hydrates Lab, and today I'm going to show you our smaller upstairs 4th floor lab, 486 in Alderson. So when we come in, it's a lot smaller than downstairs. This lab is mostly set up for our GPA projects, which is the Gas Processors Association. So over here we've got a rocking cell that we use for phase equilibrium measurements. And another cell over here. We've got a small glove box that we use for making standards. The third setup that we're in the process of getting operational. And then over here we have our Raman spectrometer that we're using to analyze phases in our microfluidic reactor. So our reactors look like this. They're about the size of a playing card, and they have this serpentine channel that is 200 microns wide for a total reactor volume just under 20 microliters. And we're able to run water and gases through this to measure equilibrium conditions via GCMS. And we can also control the temperature with our Peltier stage so that we can make it cool enough to form hydrates. So I'll show you this again when it's all set up. Okay, so this is our microfluidic system all set up. You can see we've got our pressure clamp right here with all of our inlets and outlets. It's these 4 lines coming in and out of the front. And then if we look through here, we can see where they interface with the chip. We've got O-rings. And then this is our microfluidic chip under the microscope. So we can do light microscopy and Raman spectroscopy with this. So right now, I've just got the chip set up and there's nothing in the channels. So when we look at it under the microscope, we can see our channel. So the channel is 200 micron wide. And it has rough edges since it was produced by sandblasting. But when we fill it with water, we create an annular space, so we end up having a smooth interface between the water and the gas, which is the important thing for some of the experiments that we do. So yeah, and I think next we'll have a little video that shows you what this channel looks like while it's operating. And that'll show you all the visual stuff we can do with it. But then it's also got a laser over here, and we can do Raman spectroscopy on it to confirm that we have hydrates or liquid water or what have you in our channels. So this is what a typical experiment looks like in the microfluidic channel. So we have water on the edges and gas in the middle. First we'll form ice, that you can see forming on the walls there. Next we'll come up to just above the ice point, so our ice melts and hydrates rapidly form in the channel. That's the jaws you see coming down. And then we can also find the hydrate dissociation temperature. So these are hydrates all over the channel that are now being melted right there. And then if we drop back below the dissociation temperature, they'll quickly reform.